Alright everybody, welcome back from spring break. I hope you had a good one. Now it's time to get back down to business, and now we are talking about this unit on 3D stuff, basically. It's about area and volume. I mean, there's a lot of 2D area too, but the first time we've really talked about areas at all. There's some perimeters in there, and volume of 3D objects. So we have a lot of 3D objects to define and a lot of areas to talk about. Okay, this first one is on the first two sections of chapter 11. Parallelograms, triangles, trapezoids, rhombuses, and kites. Okay, perimeters and areas. Okay, so here we go. The first thing we're going to get here is a big chart of stuff. There's just a ton of formulas in this unit. You're going to have to get familiar with them. You'll probably accidentally end up memorizing most of them, but notice this. All the above formulas will be given on the formula sheet, on the theorem sheet, but not this stuff that I highlighted here in yellow. You're not going to get these hints, but you are going to get the nitty-gritty of the algebraic-looking formulas. Okay, parallelogram. Let's start at the beginning. Now remember, when we say parallelogram, that includes everything that's more special than that still fits the definition. So this is for anything that has opposite parallel sides, any quadrilateral with opposite parallel sides, which would include these three. So this is really nice to see here. And that's the length of the base times the height. Now the thing is that you need to realize about base and height on a shape like this is the base has to be perpendicular to the height. If you're talking about a parallelogram, the two side lengths, like we had just a generic parallelogram, yeah, you'd call this length the base, but you can't call this length the height. The height would have to be, a perpendicular height like that. It has to be perpendicular to the base. So this is really small. Can I actually draw that? Oh, I can. Okay. So base and height, yeah, that will always work. Perpendicular things. And you're going to notice this in all these formulas, that the things that we multiply, generally speaking, have to be perpendicular, with very few exceptions, maybe no exceptions. The base can be any side of a figure. The height is the term given to the length of the altitude to a given base. Now, when we say altitude, we are implying, of course, perpendicular. Altitude implies, yeah, we mean perpendicular. All altitudes to a given base have to be the same length, right? So no matter where I find this height, it's always going to be the same height. That's going to be true in a parallelogram. Other parallelograms use the same formula as rectangles, however, you do not have a right angle and thus may need to use trig to find it. Yeah, okay. So if we didn't have this height, and we knew this length, and we knew this length over here, maybe an angle or something, we'd have to do some work to try to figure out that height. The area can only be computed by this length times this perpendicular length here. Okay, so be on the lookout for Pythagoras or trig if you need, which you may need to find that. Yeah, because in the end it has to be perpendicular, which is all over the trig unit also. Remember, right triangles was the only way we could do trig or Pythagoras. Triangle, length of the base times the height divided by 2. So it's the exact same thing as the parallelogram, but we're dividing by 2. So again, the length of the base can be whatever the side of the triangle is. It's this entire thing. Whoa, that's not very good, is it? This entire length of the side of the triangle could be the base. That's the base down there. Sorry, I do that really close to the edge. But the height has to be perpendicular to this. You just can't take any old side times any old side. Unless it's a right triangle, then fine. But the base and the height have to be perpendicular. And then we just divide by 2. I can show you in class, or your teacher can show you in class, why it's divided by 2, why that works. It's really pretty easy to demonstrate. You've probably seen this before. Again, altitude means we're talking about perpendicular. All right, rhombus or a kite. There's a couple ways to do this. You could do rhombus by the fact that it was up here in parallelogram. If you knew the length of the side of a rhombus and the height across it, that would work. Here's an alternate version for rhombus, but also works for kite. This is the length of one diagonal times the length of another diagonal. So I'll draw a kite here. Those two diagonals, well, guess what? They're going to be perpendicular, and that's nothing new about that. When we take diagonal 1 times diagonal 2, so diagonal 1 is like this length here, and diagonal, well, it doesn't matter which one's which, and that would be like the length of diagonal 2. Diagonal 1 times diagonal 2 times a half, or divided by 2, would give you the area of this rhombus or kite. That's like a fancy mishmash of like we're trying to find the area of two triangles at one time. That would be easy to show you that in class also if you want to see a conceptual picture of why that is. Okay. And trapezoid, this is probably the weirdest one. Trapezoid is the one where, whoa, sorry, those are supposed to be parallel. Base 1, base 2 is what they call this. Base 1 and base 2. Remember, they were defined as bases because they were parallel. We need that for a trapezoid. Those things have to be parallel. And the height is, well, still it's the height. It's the perpendicular length between those two things. So I take this length plus this length, divide it by 2 times the height. Or you can do it this way. Add them together times the height, then divide by 2. I like to think of it as the average base length times the height. That will incorporate this divided by 2 business. Yeah, but the definition of base of a trapezoid are the parallel sides. So the length of, you notice in a lot of these figures, there's a lot of lengths of sides here that don't even help. Like, I don't really need this side. I don't need these sides of this triangle. I don't need any of the sides of this thing. I don't need these non-parallel sides. There's a lot of stuff that looks like it might be helpful on these that just simply isn't. We need to boil this thing down to the perpendicular parts so we can have the ingredients for an area formula. All right, this doesn't even say, oh, this is sneaky. They just say perpendicular area of the following figure. Oh, okay, well, I got to think about what thing it is first so I know where to look back in this table for the right formula. Well, it's got opposite angles congruent. If you remember from like 6 chapters ago, anything with opposite angles congruent must be a, drum roll please, parallelogram. Okay, so this has to be a parallelogram. So I'll use the parallelogram formula, which is area is just going to be base times height. I'll put that in a different line. Area of a parallelogram is base times height. I'm going to do area first because we were just talking about area. And the length of this base, I need to find a base and a height that are perpendicular. So I can use 23 as a base. Don't use the 30. The 7 is not actually part of the shape. It's going to help us with something else, but not area. 23 times, and then the height of this thing is 24. So it's simply 23 times 24. Oh, don't make me get a calculator out. Just a second. Okay. 552. Whoops. Oh, gosh. How did I do that? All right. Perimeter, which we talked about before, we haven't really defined yet. I don't think you're going to find it very hard, is the combined lengths of all these sides. That's a parallelogram, so opposite sides are congruent. This is 23. This has to be 23. This side and this side have to be the same, but I don't really have this side yet. I have this 7 and this 24 part of a right triangle that's going to be helpful. So I got to do a little Pythagorean theorem here to figure out what that is. You do that Pythagorean theorem-wise, you're going to find out that's 25. That's a nice triple if you remember from the trig unit. So this is going to be 23 plus 25 plus 23 plus 25. That's 48 plus 48, that's 96. Hope I did that right. Hate to make errors, corrections later. All right, find the perimeter area of this thing. Well, it's a triangle. Area is going to be, again, I like starting with the area on these. It's base times height divided by 2. I got to find a base and height that are perpendicular. This 30 is perpendicular to which side of the triangle? Oh, this one. The 19 and the 30 are perpendicular, so I can use those. There's no other base and height pair given in this figure that I could possibly use. Maybe I could find one, but no. 19 times 30 divided by 2 is 19 times 30 divided by 2. Make sure it looks like what you meant here. Yeah, it's 285. Great. And the perimeter is add up all the sides. Well, it's 41 plus 19 plus, whoops. How do I find this side over here? Oh, this is 27 and 30. Does that work out nice? Is that a 3, 4, 5? No, it's not. 27 and 30? Yee. So to find this side over here, I got to go 27 squared plus 30 squared equals c squared. 27 squared plus 30 squared, because I'm looking for the hypotenuse here. Whoops. That's that. I got to take the square root of that. Square root of the answer. Gives me, yeah, some yucky number, but I might want to know what that is. Square root of 1629. You know what? I don't mind writing square root of 1629. If you want a decimal, there you go. But I'm going to write the exact square root of 1629. So this is, I'll show you how to do this because we haven't done this in a while. 41 plus 19 is 60 plus the square root of 1,629. This is really close to, total here is really close to 100, but this is the exact answer. You can leave it like that. Less calculator stuff to do. All right, find the area of the parallelogram here. All right, so I gotta do base times height. I have a nice base here of 12. I don't have a height. How on earth am I going to find that? Well, I could draw one place to draw that's right here. It's kind of nice. I could also maybe draw it here and figure out what it is. So area of the whole thing is base times height, which is 12 times I don't know, so I need to fill this in. But with this 47, I mean, this wasn't here just to be pretty. Also, this 7's probably valuable. This 7 over here would be the length of this hypotenuse. I need to find this height. Oh, look, I have a right triangle here. I know an angle. I know a hypotenuse. I need this other thing here. This looks like a job for SOHCAHTOA. In this little right triangle, I have this angle. I have the hypotenuse. I need, oh, of course, hypotenuse is h usually, and this is h for height. That's kind of confusing. I'm looking for opposite hypotenuse. Okay, I need sine. I need sine. All right, remember that. Sine of the angle equals opposite, which is h, which is a little bit, sorry, confusing. Opposite over hypotenuse. So what I want here is 7 times the sine of 47. Give me a second. Oh, am I in radians? Let's figure out if I'm in radians. Here's how you figure out if you're in radians or degrees. I'm in degrees. Okay, good. So 7 times the sine of 47 is 5.12. So the area is now, just do this, times 12, and let that ride. That's 61.43. Great. Am I going to get through this in time? I might. Find the area of an isosceles triangle with sides of 12, 12, and 10. Isosceles triangle, 12, 12, 10. Find the area. Hey, wait a minute. There's nothing perpendicular about this triangle. Well, remember, we can drop a perpendicular. Does this seem familiar yet? We did this a lot back in the day. I can call those 5. That's 12. This is yucky. 5 squared plus b squared equals 12 squared. I'm going to pause so I can get this done in one shot. All right, so the height of this thing, of course I used b for height, just as confusing as it was to use h for opposite. I just used b for height. I used, because I had this right triangle, a squared plus b squared equals c squared. So the area of this triangle is base times height divided by 2, which here is 10 for the full base, times the square root of 119 for the full height, divided by 2. I can see this right now. It's going to be 5 times the square root of 119. You can leave it just like that. Okay. Find the area of this thing. All right, so I could do base times height. Like I could use, base, and I could find a perpendicular distance. Or I could try to do diagonal 1 times diagonal 2 divided by 2. I like that better. Whoa, that was really kind of a miss. All right, so let me fix that. All right, so the area of this thing is going to be d1 times d2 divided by 2. d1 I'm going to call 14. I need the other diagonal, which is the distance from A to C. Well, this is 7. This is a right triangle. I could use Pythagorean theorem and find this whole thing. I'll start using x's for this. X squared plus 7 squared equals 18 squared. Look how much Pythagoras I've used today. And I find out that that diagonal, half of that diagonal, this little part here, is the square root of 275. So it's the square root of 275, and there's actually 2 of those. 2's cancel, and I get 14 times the square root of 275. That's a 7 right there, by the way. All right, and last one. Find the area of this thing. Well, for kites, really the only one we had, see if I can do a better job here. Kites, really the only one we had was diagonal 1 times diagonal 2 divided by 2. One of the diagonals is given, isn't it? Yeah, it's 20. But I need that other diagonal first. I need the length of this diagonal. I got to do some trig over here. If this is a 30, 60, 90, this is 60, this is 10. Then I know this is 20. This is 10 times the square root of 3, if you remember. If this is 10 and this is 12, I can do Pythagorean theorem again. X squared plus 10 squared equals 12 squared. So x is going to be the square root of 44. So this is the square root of 44. This entire diagonal is the square root of 44 plus 10 square root 3. I'm going to do that on the calculator. Well, if I do that on the calculator, it's really not very pretty. Oh, and then the next thing I do is divide that by 2. I get this crazy answer. I just kind of want a decimal for that. Let's call that 239.54. All right, check my formulas. I hope I haven't made any mistakes. First one to catch a mistake gets, gets some kind of prize. Okay, great. I'll see you in class.